So, today we are going to discuss about principle of superposition. So, principle of superposition is nothing but sometimes a body is subjected to a number of forces acting on its outer edges as well as at some other sections along the length of the body. Say for example, this is the body and the body is divided into two sections. This is point A, point B and point C, and point A at point C some forces are acting which is equal to 50 kilonewton and 80 kilonewton, right, and sometimes at body B some force is also acting which is equal to 30 kilonewton, right. So, in such cases the forces are split up and their effects are considered on individual sections. Say for example, first we have to take, so here the 80 kilonewton tensile force is acting at A and 50 kilonewton tensile force is acting at C. So, here we have to divide this 80 into 30 and 50, right. Then the resulting for deformation of the body is equal to the algebraic sum of the deformation of the individual sections. Let us take first A, B and A, C. Now, we have to calculate this one separately and this one separately, and final resulting deformation is the sum of algebraic sum of these two individual sections, right. So, this resultant deformation is called a principle of superposition, right. So, now we are going to discuss the deflection del L. Already we discussed in our previous video, del L which is equal to P L by AE, right. So, P which is equal to load acting on the section, and L which is equal to length of the section, and A which is equal to cross sectional area of the shaft, and E which is equal to Young's modulus. So, which is equal to, so area of the cross section of the bar and Young's modulus both are constant. So, take out 1 by AE, right. So, here the thing is the load changes and length changes according to the sections, right. So, P1 L1 plus P2 L2, here two sections are there, right. This is section 1 AB and section 2 AC, right. So, P1 L1, P1 which is equal to the force acting on section 1, right, then L1 which is equal to the length of section 1. Similarly, P2 which is equal to the force acting on section 2, right. So, L2 which is equal to length of the section 2, right. So, corresponding values, if suppose the bar is having some other sections, right, third section, then the P3 and L3 are corresponding values of section 3 and so on, right. Now, let us discuss a simple problem related to this. Now, a steel bar of cross sectional area 200 mm squared is loaded as shown in the figure. Find the change in length of the bar. Take E as 200 gigapascal. The given data are cross sectional area of the corresponding bar which is equal to 200 mm squared, and the loads are 50 kilonewton tensile force is acting at A, and here the B 20 kilonewton is acting outward, right. This is also a tensile force at B, and similarly at point C 30 kilonewton force is acting, the tensile force is acting, right. So, now for what they are asking, find the change in length, del L they are asking, del L which is equal to, already we know that P L by AE, right. So, this is different sections are there, right, multiple sections are there, that is why multiple sections P1 and L, P and L both are changing, and A and E which is a constant. So, we have to take A, E, and here two sections are there, right. So, first for sake of simplification, the forces 50 kilonewton is split up into two forces, right, which is equal to 20 kilonewton and 30 kilonewton, right. So, 50 is divided into 20 kilonewton and 30 kilonewton. If we want to take 20 kilonewton at point A, then we have to consider A B, which is the 20 kilonewton acting at point B. So, first we have to take the section 1, which is, this is section 1 at left side at point A and right side at point B, right. So, at point A 20 kilonewton tensile force is acting, similarly at point B as it is 20 kilonewton is acting according to the given data, right. Similarly, section 2, here remaining 30 kilonewton is acting at point A, then here at point C 30 kilonewton tensile force is acting. Now, let us take the second section which is at point A 30 kilonewton and similarly at point C 30 kilonewton, right, at point C. this is B, right. So, now what is the formula? Del L, which is equal to 1 by AE into P1 L1, P1 which is equal to 20 kilonewton. So, 20 into 10 to the power of 3 into L1, which is equal to what is the length? 300 mm, right. So, 300 mm, 300, right. So, this is first one, plus the second section, which is equal to P2 L2, P2 which is equal to 30 kilonewton, 30 into 10 to the power of 3 into what is L2, L2 which is equal to the length of AC, AC which is equal to 500 plus 800, which is equal 500 plus 300, which is equal to 800. So, 800, right. So, what is the value of A, which is equal to 200 mm squared, E Young's modulus, which is equal to 200 gigapascal, right. We have to convert into Newton per mm squared, right, because here the 300 mm and 800 values and 300 values are in terms of mm only. So, we have to convert this gigapascal into Newton per mm squared, right. Substitute all the values and you will get, which is equal to del L, which is equal to 0.75 mm. So, this is the answer, right. Similarly, we have to take the second problem. It is a similar same problem, but sections are different, sections are there, right. So, a brass bar having cross sectional area of 500 mm squared is subjected to axial forces as shown in the figure. Young's modulus, which is equal to 8 gigapascal, change in length of the bar, del L they are asking, right, del L which is equal to PL by AE. How many sections are there? Here at point A 100 kilonewton is acting, at point B 80 tensile force, at point C 50 tensile force, and point D 30 kilonewton compressive force, right. So, now for for sake of simplification, we have to divide this 100 kilonewton into several split ups according to the other forces, right. Let us take first case 1, which is equal to case 1 or section 1, right. Let us take A, B, right. So, at point A, B which is equal to 80, right. So, this is 80. So, we have to take 80 kilonewton, remaining 20 kilonewton is acting still at point A, right. Now, at point C 50 kilonewton is there, 50 we have to divide into 2, one is 20 plus another one is 30, right, because this is according to a point C, this is a compressive force, right. So, now section 2, at point A remaining 20 kilonewton is there, right, this is 20 kilonewton remaining, and at point C, which is equal to, this is C point and this is A point, this is A and this is B. So, at C point, which is 20 kilonewton, right. So, here 20 over, remaining 30 is there. Now, we have to take third section, which is equal to what? This is at point C and this is at point D. So, point C compressive force, point D compressive force, which is equal to 30 kilonewton and this is 30 kilonewton. So, these sections are well balanced. Now, substitute the values, del L which is equal to 1 by A, which is equal to 500 mm squared. So, 500 cross sectional area 500 into E, which is equal to 80 gigapascal. 80 gigapascal is converted into Newton per mm squared, right. And what is the L length of AB section? 500. So, this is 500 mm, and what about AC? AC which is equal to 500 plus 1000, which is equal to 1500 mm, right. This is L value, L which is equal to 50, in this case L which is equal to 150, sorry 1500 mm. What about CD? CD which is equal to 1200 mm, the length between C point and D point, which is equal to 1200 mm. So, these values are mm value. So, we have to convert this gigapascal 80 gigapascal into Newton per mm square, or otherwise we have to convert these values into meter and this 80 gigapascal into Newton per meter squared, and this value is also we have to convert into meter. So, instead of that we have to convert this 80 gigapascal into Newton per mm squared, that is easy way, right, into either this is into 10 to the power of 3, Newton per mm square into P, which is equal to what is the value? 80, right? 80 into 10 to the power of 3 plus so into L, which is equal to 500 mm, 500. This is first section. Second one, which is equal to what? How much? 20 kilonewton. So 20 into 10 to the power of 3 into what is the value of L, which is equal to 1500. So last one, third category, which is equal to 30 kilonewton. 30 into 10 to the power of 3 into what is the value? 1200, right? So simplify this, we will get del L. So you have to simplify, then so sorry, here the thing is the section 1, which is a tensile force, section 2, which is a tensile force, whereas section 3, which is a compressive force. So for that, this is section 1 and this is section 2. We have to add algebraic sum of these two, because section 1 and section 2 both are the tensile force is acting at section 1, section 2, whereas for section 3 it is a compressive force. So we have to subtract this value, right? So first section plus second section minus third section, because in third section the force is acting, which is a compressive force, that is why, right? So simplify all those things, then you will get the value 0.85 mm, right? So this is the value. Clear? So remaining problems we will discuss in our next video. Okay, thank you.